Okay, so we got gravel falling in a cone, a conical pile, at 4 meters cubed per hour. Okay, so now we know that volume is a function of time, and we know that the change in volume over the change in time is equal to 4. We're also told that the diameter is always double the height. So there's a relationship given here because this question has diameter, it has height, it has volume, so we've got multiple variables. Last questions we did only had 2 variables, just radius and surface area. Now we have a third variable with height, but we're given something that relates the diameter to the height. We want to find the rate of change of the height, so we want to find dH dt, which is telling us that height is also a function of time at the moment that the height is 3 meters.
So that would be dH dt.
No, dH dt is what they said, can you find the rate of change of the height? And we want to find it at h equals 3.
But we know the diameter now.
So the diameter would then be, at that time, 6.
And the radius would be.
And the radius would be 3. We'll probably need to know the radius because how do you find the volume of a cylinder? So now this is the part where you have to figure out how can I write the formula for volume of a cylinder? Volume of cone with height. Now, the volume of a cone is just a cylinder. Here's my formula for a cylinder. And a volume of a cone is 1/3 of a cylinder.
Can you just do all divided by 3?
You could have it all divided by 3. That would be fine as well. Now, the problem with this is there's 3 variables, but there's a relationship between the radius and the height. The radius and the height are equal, because if the diameter is this, the diameter is 2 radiuses, so,
The radius is 3.
well, that's a specific time. At the specific time that the radius is 3, we want to find it, but we're going to need to create our formula for all times. So the volume, in this case, is always going to be 1/3 pi. Instead of r, I can write h, and h squared times h would be h cubed. This time I'm wanting to use h because we could do it and make it all in terms of r, but the question was asking, find the rate of change of the height. So since we're finding dH dt, it's going to be exactly the same. You can probably see that dr dt and dH dt, since the radius and the height are always the same, they'll be increasing at the same rate. So it would be exactly the same answer. So now we can take the derivative of this whole thing with respect to time. Derivative of v would just be 1, and then chain rule would give us dv dt. Derivative of this, the 3 would come out in front, nicely multiplies by that 1/3, which will just give you pi h squared, and then the chain rule would say the derivative of h is dH dt. So now let's say, what do we all know? We want to find this dH dt out. Do we know dV dt?
No.
Yes.
Maybe? Maybe if we like looked above and said, hey, there it is.
Oh,
Oh, 4. There it is. So this will be 4. At what height do we want to find it?
3.
At 3. dH dt. Simplifying this, dividing everything to get dH dt by itself would be 4 over 9 pi, which is, fast fingers, 1.4. Can you try that again by using the proper brackets?
1.27. 1.27323954447.
I will do the mental math first and go 0 point. Because it's going to be 4 over 27, which as far as I know is less than 1.
It's
0.14. Yeah, I'm recording this. So it's 0.14. We've got, our height was in meters, and our time was in hours. So there we have our final answer.